going to finish up chapter or section 4.5, I should say. And we have one more discussion here about lines. We're going to talk about parallel and perpendicular lines. And this is an idea that you'll be expected to carry throughout the rest of your algebra math career as well. So parallel lines are two lines where they have identical slopes. And if you think about it, so let's make a couple up here. Suppose I had these two lines. Well, they have different y-intercepts. Let me show you here. So if I were building the top line, I'd start at 2, go up 3 over 2, up 3 over 2, and I would make my line. Well, the other one starts at 4, but it has the identical slope, up 3 over 2, up 3 over 2. So do you see, I would be making parallel lines like railroad tracks. And coincidentally, these lines would never touch each other because they're parallel. Now, the point here, though, is parallel lines have identical slopes, but different y-intercepts. So they start at different places, but they build in the same way, and so they would never touch, which is the definition of parallel lines. So same slope. So the common question is, let's take a look at two different lines, and let's see if they're parallel. Now, this one is already set up. I see that my slope is 3 over 2. This one is not. So I'm going to rearrange this into slope-intercept form so I can find the slope. Now, we did this earlier. What I would do is move this whole 3x to the other side, like that. Do you remember that? So I'd have negative 3x plus 6. Now I divide both sides by negative 2. That whole side. So remember all this. So y, now I'm going to give the negative 2 to the 3 and the negative 2 to the 6. So it became 3 halves x, and then when it goes in here, there it's minus 3. Now look at my slopes. I have a 3/2 slope on the first one and a 3/2 slope on the second. Sorry, I'm losing my voice. So these have the same slope. These are parallel lines. So that could be, you could use that symbol or you could write this out. So we got parallel because they have identical slopes. Now let's try it again here, or let's see, let's let them do it. Yeah, let them do the hard work for us. So this first one has a slope of 2 over 1. It's already in slope-intercept form. Now they rearrange this one, do all the work I just did here, and they get a slope in front of the x is 2 over 1. So these are identical slopes. These must be parallel. Oh, hold on. Did they trick us here? Oh, yeah, sorry. I didn't look at the very end of this punchline here. So hold on. They do have identical slopes, but they also have the same starting point. So they're not parallel. These are actually the identical line. Okay, so when we arranged this, we found the same line. So remember what I said, it's the same slope, but you got to start at a different point. If you start at the very same point, this is the very same line. These two lines are right on top of each other. So let's try a few of these. I'm going to solve, this is already tells us I have a slope of negative 2 over 5. So let's work with this one. So we've seen this before. I'm going to get this out of that room. I'm going to treat it like it's all just one big number. Get this. Now divide by 5 there. I'm going to do it to the whole other side. So I got to give the 5 to both of them. So negative 2/5 x. 5 and a 5 goes once. So I have the same slope and I have different y-intercepts. These are two parallel lines. Now let's try it again. I know my slope over here is negative 1/2. So I'm going to just use what they started. I'm going to subtract an x away to get him to leave. I have 2y equals negative x minus 2. Divide by 2 there. I got to do it to the whole other side. Now there's really a negative 1 there. So this becomes negative 1/2 x. And 2 into negative 2. You got to do it into both. I get negative 1. So look what we have here. Although they have the same slope, once again, they start at the same y-intercept. So these are the same line. So they're not parallel because they're actually right on top of each other. Okay, now I always think this is kind of a fun question. So if y equals, let's see if they graphed them. No, they didn't. So if y is always negative 4, remember we saw that made a horizontal line. Well, how about y is always 3? Well, don't these each make horizontal lines? Well, horizontal lines have the same slope, and they're going to be parallel. Can't you just see they're parallel because we got two horizontal lines? So those are going to be parallel. And then if we did it again with x's, we're going to see something similar, except we're going to go vertical. X is always negative 2. X is always negative 5. These are parallel. Now they're going a different direction. They're going vertically, but they're still parallel. Okay, so I won't draw these. They're both going to be parallel. These are going to be horizontal, these are going to be vertical, but they're still parallel. Now, perpendicular. Do you remember what perpendicular means? It means, and I'm going to have a hard time drawing this, these are perpendicular if they strike each other and they create 90-degree angles. It's like a perfect street corner. Like it's 90, all the corners are perfect. All of them are 90 degrees. Now, it's a little bit odd. It isn't as simple as to find perpendicular lines. You turn this, so if this is my first slope, a perpendicular line, you turn it upside down and make it 3 over 2. But you also have to change the sign. So suppose the line was going like this. To have it build in the other direction, it has to be negative. It has to be going, if one was going uphill, the other one has to go downhill, or else they wouldn't be able to strike each other in that fashion. And then they're built in the exact opposite way, in the sense that the rise and run switch places. So let me show you with some here. Well, let me show you here. Oh, it doesn't work that way. I cut that wrong. Okay, so I've got this one already. So this is this one. My slope for that line is negative 5 over 1, right? Now we're going to do the same thing we did to solve this second one. Where is it? I'm solving the second one for y, doing the same thing we did. Now look here. I've got 1 over 5. So that's it. It's upside down, and it has the opposite sign. These must be parallel. Or I'm sorry, these must be perpendicular. And I don't know how to spell perpendicular. So those are perpendicular. Now let's try another one. So yeah, these, okay, they didn't set these up. So they gave two that we got to put into slope-intercept form. So I'm going to jump ahead to them solving them. Now, it was pretty complicated with the fractions, but look at the two slopes. The slope for this one is negative 7 over 2, and this one is negative 2 over 7. They are upside down. They are what's called reciprocals, but the signs are the same. Those are not parallel, or perpendicular. I'm sorry I keep saying that. These are not perpendicular, because we have to be upside down, we have to be reciprocals, and we have to change signs. All right, let's check some more here. So I know this one has a slope of negative 3 over 1. Let's see about this one. I'm moving that x across. Now I'm going to do it a little faster. I'm sending that across, dividing by negative 3. So y is, now remember how we did this here, so it's going into all of it. It's a negative 1, negative 3 would be 1/3 x, and negative 3 into 4, negative 4/3 is the best we could do. Now look at these slopes. This was negative 3 over 1. This is 1/3. So they're turned upside down. They're reciprocals, and the sign has changed. These are, that's the fancy symbol for perpendicular. Let's try the other one here. Now, I'm going to do this one first. Now, I'm just sending over the negative 5x. I'm just doing this for time, and we've seen it many times, so hopefully you're with me on this. Going kind of quick. Giving the 4 to both parts. So that's one of them in slope-intercept. Let's try this one. I'd have 5y is negative 4x plus 3, dividing both sides by the 5. I'd have y is negative 4/5 x plus 3 over 5. All right, now let's take a look at the slopes. Now they're upside down from each other. They're reciprocals, but the signs are the same. So those two lines, they are not perpendicular. Oh, well. I thought there'd be more of those. That can actually be a pretty extensive topic sometimes, but I guess we're just introducing this in kind of a introductory way here, since this is our first crack at algebra. So remember, check the slopes for parallel if they have the identical slope and start with different y-intercepts. They can't have the same y-intercept, but if they have different y-intercepts and the same slope, they're parallel. If they have slopes that are reciprocals of each other, meaning they're upside down and have the opposite sign, then they're perpendicular.